Hello friends, welcome again to this channel. So let us get the current divider theorem. This is an established equation wherein you can easily get the value of the current in the branches. But this applied only to two resistors connected in parallel. To be able for us to get the equation, let us have a resistor, say R1, and another resistor, say R2, connected in parallel. So this is it. Now, let us pass through the current here from this node A and B. From A, let us say this current is I sub T, which is the total current. When it comes through this point, this I sub T will separate. There will be some of the part of this current will go through R sub 2 and named this I sub 2, and another part will go through R sub 1 and name this as I sub 1. Actually, we can also have an equation for the total resistances, or we can write these two resistors into a single resistor such as R sub T. Again, this is your I sub T. But what is R sub T? We have already derived or shown you into the previous video on how to get the total resistances of a parallel connected resistor. But in this case, for a quick review, so we have R sub T here. We know that I sub T is equals to I sub 1 and I sub 2. Using Ohm's law here, let us use Ohm's law, where it states that V is equals to I in R. So to be able for us to solve for I, just divide V over R. So the value of I sub T using V and R is V sub T over R sub T. Okay, so the value here is your V sub T, which is equals to V sub 1 over R sub 1. Okay, let me just show to you. Plus V sub 2 over R sub 2 here. So here is V sub 2, here is V sub 1. Okay, and we know that V sub T is equals to V sub 1, which is also equal to V sub 2. So therefore we can change V sub 1 to V sub T over R1, and this will also be V sub T over R2. So we can factor out V sub T. So we are now writing V sub T as the common factor. Okay, what remains inside the parenthesis is 1 over R1 and 1 over R2. So we cancel this out. So we have 1 over RT, which is equals to 1 over R1 plus 1 over R2. So therefore, we can also have the simplified form of this two terms. We have R1 and R2 as our LCD, the least common denominator, and we divide it here. So R1 will be cancelled out. What remains is R2. For the other term is the one that is cancelled out is R2, and what remains is R1. So 1 over RT is equals to 1 RT plus R1 over R1 and R2. So we just cross multiply to be able for us to get RT. So RT is equals to R1 and R2 over R1 plus R2. Okay, now let's get the current divider theorem. So we know for a fact that B sub t is equals to B sub 1 or equals to B sub 2. Now let us use this relationship. B sub t is equals to B sub 1. So to be able for us to have B sub t in terms of the current and the resistance using Ohm's law, you have I sub t, okay, times R sub t. And for B sub 1, you have I sub 1 times R sub 1. So you just substitute RT here. Instead of writing RT, we write the other resistances, which is, okay, R1, R2 divided by R1 plus R2, which is equals to I1 and R1. Okay, so we are now solving for the branch current. So the branch current in this case is I1, this one. To be able to solve for that, we just again cross multiply. Actually, we can rearrange. We can put this term on the right side and this term on the left side. So it will just be like this one. I1 R1 is equals to I sub t R1 R2 all over R1 plus R2. So you notice also that on the left side and the right side, the common are R1, so just cancel it out. So this is now the equation or the current divider theorem established equation for I1 for the branch here, in which I1 is passing to R1. So I1 is IT times R2 all over R1 plus R2. So this is how you get R1. This will be your established equation or the current divider theorem. Now for your R2, it will be all over the same setup, but instead of equating B sub 1 to B sub t, you equate B sub 2. And then you just substitute again R sub t and you will find the same equation. But what you are looking for is I sub t. I sub 2. So for I sub 2, that will be I sub 2 is equals to I sub t R sub but since this is I sub 2, that will be R sub 1. You will notice that what will be cancelled out there is your R sub 2, and what will remain is R sub 1. So R1 plus R sub 2. Okay, so this is now the equation. So for your current divider theorem, it's so easy to memorize. Now if you are looking for I sub 1, okay, you just multiply the total current to the branch R2. So you are looking for this I sub 1. You multiply the total current to the branch in which you are not the other branch, which is R2, and then divide it by the summation of the resistances. For I sub 2 here, you multiply IT to the other branch, which is R1, and then you add R1 and R2. So this is it. This is how you have your current divider theorem. Thank you.